This video is for lesson 6-2, two-column geometric proofs. Our learning goals are to make two-column proofs, to prove theorems about segments, and to make two-column proofs to prove theorems about angles. Earlier we wrote two-column proofs to solve algebra equations. We justified each statement in the proofs using an algebraic property. Now we're going to do two-column proofs to prove geometric theorems. So we have to justify each statement using a definition, a postulate, a property, or a previously proven theorem. Recall that vertical angles are opposite angles formed by a pair of intersecting lines. In the figure below, angle 1 and angle 2 are vertical angles. The following example illustrates how to prove that vertical angles are congruent. So for example, in this picture, this one and this one are vertical angles, and already this year we've concluded that those are congruent to each other. In example A, that is proved. The first statement of this proof is to use this drawing and the observation that angle 1 and angle 3 create that straight line. And so we can say the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. The reason for that is the definition of supplementary angles. Notice that angle 3 and angle 2 lie along that straight line. So those two add up to equal 180. Again, the definition of supplementary angles. Next, let's take the first and second statement and combine them together, because if they're both equal to 180, then that means they are equal to each other. That's the substitution property. Basically substituting angle 2 and angle 3 in place of the 180. And that creates this equation. The next step, we can subtract the measure of angle 3 from both sides to create the measure of angle 1 is equal to the measure of angle 2. That was using the subtraction property. And if the measures are equal, that means the angles are congruent. The definition of congruent angles. In this example, we had a given situation, this drawing and these angles being in vertical positions, and we were trying to prove this conclusion. And we were able to do that by moving step by step. Here's example B. Supply the missing statements and reasons. The theorem that we're trying to prove is that all right angles are congruent. So here's some given information. Angle A and angle B are right angles. Let's prove that they're congruent. So as is usually the case, the very first statement of a proof is to write down the given information. So in this blank spot, we're copying down angle A and angle B are right angles. Because they are right angles, in the next statement we can say that the measure is equal to 90. And that's the definition of right angle. Because the measure of angle A is equal to 90 and the measure of angle B is equal to 90, we can conclude that the measure of angle A is equal to the measure of angle B. If they're both equal to 90, then they equal to each other. That's substitution. And if their measures are equal, then they are congruent to each other. So we were able to create the statement that we were trying to prove. And that's the definition of congruent angles. Notice that to be able to give reasons for our thinking, we have to have the knowledge from previous sections this year, the different definitions of words, the different algebra properties, and so on. Here's another example. Complete the proof. Given that Q is the midpoint of PR. So in the drawing, if Q is the midpoint, that and that are congruent. And that segment QR is congruent to segment RS. So not only is this segment the same length as this, but it's also the same length as this. as I've shown with the little purple marks. Let's prove that segment PQ, that's this piece, is congruent to segment RS, this piece. Okay, Q is the midpoint. That was given information. Segment PQ is congruent to segment QR. How do we know that? How did I know that I could put a mark here and a mark here? Well, the reason is the definition of midpoint. The definition of midpoint said that a midpoint splits a segment in half, creating congruent pieces. Okay, next statement. Segment QR is congruent to segment RS. That was given information. And finally, segment PQ is congruent to segment RS. So it's got to be some kind of combination of the previous statements. If PQ is congruent to QR and QR is congruent to RS, then we can say that PQ is congruent to RS. That pattern of logic where you're making that connection is called the transitive property. And here's another example. This time it's the statements that are missing. So given that angle 1 and angle 2 are supplementary, and that angle 1 is 68 degrees, let's prove that angle 2 measures 112 degrees. Okay, so the first statement has to go with the word given. And so look up here at what's given. Angle 1 and angle 2 are supplementary. Okay, in the next one, notice that the reason is the definition of supplementary angles. So if that's the reason for making some kind of assertion, what would be a logical assertion that was made from that previous step? Well, the definition of supplementary angles says that if angles are supplements, then their measures add to 180 degrees. Next, we have some more given information. Well, okay, how about this part here about the measure of angle 1 is equal to 68 degrees. Okay, next statement. Apparently, the substitution property is going to be used. So looking at the two previous ones, what could be substituted for what? How about putting 68 in place of the measure of angle 1? And then in the final statement, we're going to use the subtraction property of equality. So that means that something's going to be subtracted from both sides. Probably the 68. And 180 subtract 68 is 112 degrees. So we've created what we were trying to prove by working step by step from given information to what we were trying to get, and provided a reason each time. So it's a little bit strange this time to have reasons given without statements. Usually it's the other way around, or both statements and reasons are missing and we have to create proofs completely on our own. Here's example C. Arrange the statements and reasons below in a logical order to complete the proof. What we're trying to prove is this theorem. If two angles are complementary to the same angle, then the two angles are congruent. Given information is angle A and angle B are complementary to angle C. Then let's prove that angle A is congruent to angle B. Here are some drawings to assist us. So what we're asked to do in this example is put things in a logical order. Well, you know how proofs often begin with the given information? So it's this right here that needs to be step 1. Now, you know how proofs always end in what you're trying to prove? So then, of the 5 steps listed here, what we're trying to prove is that last step, step 5. So how can we get from step 1 to step 5? Okay, let's go back to step 1. If we know that they're complementary to angle C, what can we conclude from that? Well, being complementary means that the measure of their angles adds up to 90. That's the definition of complementary angles. So that would be the second thing. Now, once we have this statement, what would be something that you could conclude from this? Well, we could say that because both things are equal to 90, then these are equal to each other. And then that would make this first one up here the third statement in the proof. And then from this step, we could subtract angle C from both sides using the subtraction property to create this. And so that's the fourth one. So what this example was about is us putting things in the right order to show that we can make a logical step-by-step argument. Here is a try these question, so I'll pause the video for you to put these statements in order. Okay, next problem. Write a two-column proof of the following theorem. The theorem is, if two angles are supplementary to the same angle, then the two angles are congruent. This is very similar to the one that we had done just a little bit ago about two angles being complementary to the same angle. So the logic of the proof is going to be very similar. So you start by making a two-column chart. The first column will contain the statements, and the second column will have our reasons. Begin with the given information. So angle R and angle S are supplementary to angle T, given. If we just said that they're supplementary to angle T, then the logical thing to conclude is that the measure of angle R plus the measure of angle T is 180 degrees. And likewise, we can say that the measure of angle S plus the measure of angle T is equal to 180 degrees. That's the definition of supplementary angles. From this statement, what could we do? Well, the fact that both things are equal to 180 allows us to conclude that they're equal to each other. Basically, what's going on is this expression is being substituted in place of the 180. So this is the substitution property. The reason that that's helpful is because it creates a math equation. Remember that measures are numbers. So that opens up the whole realm of algebra properties to us. We can solve this equation by subtracting the measure of angle T from both sides. That creates the measure of angle R equals the measure of angle S. That's the subtraction property. All along, I've been keeping in mind what I'm trying to create. Angle R is congruent to angle S. Once I know that their measures are equal, I can then immediately go to angle R is congruent to angle S. That's the definition of congruent angles. Starting with the given information, I'm keeping in mind what my goal is, and I'm working step to step to step using definitions and properties that I'm aware of. Here are some check your understanding questions. So in this video, we did some examples of two-column proofs about segments and examples about angles. Some of our examples had the statements all filled in and we had to provide the reasons. We did an example that had the reverse. The statements were missing, but the reasons were there. But really what the goal is for you to be able to do proofs all on your own. Start with the given and then work step by step all the way to what you're trying to prove.